Hey guys, hey, we're back here with Zach. We got this VP44 ejection pump here on the table, and Zach wants to go through a little teardown and he's going to explain to us how this pump works. So I'm going to turn it over to Zach.
All right, we've got a VP44 here off of a Cummins 5.9 liter ISB. They started using these halfway through the 1998 model year to meet the stricter emissions regulations that just came out. It was kind of a carryover between the P7100 that wasn't up to meeting the new standards and the common rail injection that wasn't quite ready yet. They used these from 1998 and a half all the way through 2002. They had them a little while earlier in Europe, and I think they hung around later in some other applications, but really in the US the Cummins 5.9 was the most common. So this pump here is an electronically controlled radial piston distributor pump, and we'll kind of get into what that means. For the distributor portion, first of all, you can kind of see on the back of it, it almost looks like a distributor off of an old carbureted engine. The fuel comes out in a rotation, with the firing order, obviously, as the pump shaft rotates. And you can see we've got our fuel solenoid here. Normally there's a pump mounted computer up top. They call that a PSG. That controls the fuel solenoid. We've got a timing solenoid here that it controls. You can kind of see in the bottom we've got this timing piston bore. This slides back and forth, and we'll get all into that when it's torn apart. But normally this pump mounted computer interfaces with the vehicle over CAN, and that controls the fuel message, the timing message. It's got a crankshaft signal that goes into it, and I think that's the most of it. So we'll start by tearing the electronics off, and we'll kind of get you guys filled in as it's coming apart. So underneath this cover here, we've got our little sensor. This reads a tone wheel inside the pump that's right on the camshaft. What's kind of interesting about this is the sensor moves with the timing piston, so it keeps the position of the injection events. Really, it's keeping the position of the cam ring, so that as the cam ring moves back and forth, you can kind of see down in here maybe there's a little mount for it, and as that piston moves, you can see the sensor moves back and forth. They're going to see my specially designed solenoid puller. Right here we've got the fuel solenoid. Not a lot to see. Really at this point it's just a magnetic coil. All the action happens in the back here, and again we'll show you that as we get further into it. But it's just a really strong coil. It's sealed in the back with an O-ring. You really got to yank it out. But and now you can see here we've got our timing solenoid, and that's really the extent of the electronics. This is really all the interfaces with the pump. Normally when you've got the computer on here, there's a fuel temperature sensor that's mounted to this board, and you can see the fuel is actually filled up in this cavity, so it picks up on that. I said earlier we've got our little sensor here that reads the tone wheel inside the pump, and then the fuel solenoid and the timing solenoid, and that's really all that controls the physical pump itself. The rest of it is all mechanical, and we'll start diving into that. So now that we got it torn down to this point, we'll go over the fuel flow path and how everything works in there. We've got our inlet here for the lift pump, and this is our overflow valve port. This is the port that returns all the excess, and actually what's kind of interesting about the overflow valve on these, there's a little bleed down port, so even if you are below the, I think 14 psi is what they open at, you're always getting some sort of fuel flow. So you're always getting fuel in here, which helps keep the pump computer cooled, and more importantly you're getting fuel into this cavity here, which leads down and over to this vane pump in the very front of the pump. So this internal vane pump does all of the work to feed the distributor head that does the main fueling, and it also feeds the timing piston. You can kind of see we've got our little regulator valve here. This is just spring controlled. There's no adjustment on it. This cavity down here, you can follow it down. You've got another ridge here, and you can kind of see where the fuel is going to. So you can follow it over to the timing piston, and eventually, I think this one right here is the return that returns the excess from the timing piston as that solenoid cycles it back and forth. So you've got really 3 pressure stages in this pump. You've got your lift pump pressure stage, you've got your vane pump pressure stage, and you've got your high pressure injection pressure stage. So we'll go ahead and tear the distributor head off, and we'll cover that injection stage right now. All right, so now we'll go ahead and get the distributor head out. We'll show the injection pressure stage and how all that works. You might see a couple parts falling while we take it out, but we'll go over that. Normally there's some O-rings. It's kind of a pain to pull this thing apart, but we've had it apart before, so we just left that all out. If you are tearing one of these apart yourself, it's helpful to stand the pump on its end, and I'll show you why that is. Now that we've got this out, we'll go ahead and lay that back down. It just comes right up. This is the actual pumping portion. This is what does all the work, all the high pressure pumping. You've got these plungers right here. You can see we've got 3 of them. We rotate it around, and this is the drive tangs that is actually connected to the pump shaft. So we've got these 3 right here. I think these ones are 7.5 millimeter, something like that. I know there's 2 different variants. There's the high output pumps, at least for the Cummins, and then there's the standard output pumps. The high output pumps actually have smaller plungers in them, so they're capable of less fuel delivery. The actual raw fuel capability is less, but the reason they did that is the smaller piston gives you less cam loading, so that's what helps the pump live. But really, if you're trying to make big power, these pistons here, or these pump heads, are what you want to go for. So as these move in and out, I can't move all 3 of them at a time, but these are actually compressing the fuel that's in here, and depending on the rotation of this guy, that dictates which of these outputs it goes to. So I think this here is our feed passage to it. This is coming from that vane pump. We've got our return passage here. This actually feeds back, and so the the solenoid on this, what it does is every rotation, or I guess every cycle, these pistons have to move up and down the full amount. You're not controlling the stroke of these. What you're doing is controlling how much fuel goes out the injector. So when that solenoid turns on, what it's doing is actually moving, it's kind of hard to see, it's moving this needle back and forth, and it's kind of similar to a common rail injector, at least in principle. So as this needle moves in and out, it really doesn't move a ton, but what you're doing is dictating whether the fuel goes out the distributor head, whichever one's lined up at the time, or whether it returns back into this diaphragm cavity. And we'll talk about that for a second here, because this is something I think a lot of guys never really had a good understanding of. This diaphragm is ultimately separating the lift pump pressure stage of the pump from the vane pump pressure stage. There used to be a myth floating around that too much lift pump pressure would crack the diaphragm. That might have been the case with, I heard there was an old plastic one, but I don't think it would have been lift pump pressure that cracks it. Rather, the fuel that's returned. If you're injecting, more fuel, if you got a programmer on it or something, maybe the return flow is higher. And I think, if anything, that could have been what was cracking it, or maybe higher RPM, something like that. But really, I don't think the lift pump pressure is something that would have cracked this, because really what this diaphragm's job is to do when you're injecting these pumps, I think they go up to somewhere around 1,200 bar. So you've got all this pressure. It's I'm not exactly sure on the number. I can't do the calculation. Somewhere around maybe 20,000 psi of pressure could be coming out when you end the injection, when you open that solenoid again, and that comes right back into this cavity, so it can be used on the next injection stage, instead of the vane pump doing all of the work and having to return all of the fuel for every single injection event. This diaphragm here kind of dampens those pulses. So now we'll go ahead and pull the needle out. That's what I was saying controls the injection. Got 2 little Torx 10 bolts in here, and this thing should come out. So this little guy right here, and you can kind of see, maybe you can't see actually, this is about the most motion it's going to have. This much movement back and forth is what's dictating whether the fuel is getting injected or out the distributor head, or whether it's going back to the diaphragm cavity to be used on the next injection event. And that all happens, I guess we can pull this out, but that's all happening right inside of here. There's a number of cavities that it's coming from the vane pump and it's going out the distributor head. So you can kind of see we've got these various holes in here that really dictate the fuel path. As this rotates around, it's these holes are lining up with a different port, and it's feeding the fuel to a different injector. And this is something that's very, very precise. Just the sealing on this, the precise fitment is what dictates the sealing on it. So there's no O-rings, no gaskets or piston rings or any of that. It's metal on metal, and it's very precise. And the same goes for this needle actually. So this is something, if you ever feel like tearing apart a pump, I'd recommend it's not one you don't want to run again, because there's any bit of contamination when the tolerances are this tight. You can see something up, and on this pump I don't think it'll cause a runaway. That's more of a problem on the P7100s, but you can certainly cause some damage with even the slightest bit of contamination. So unless you're in a clean room and you really know what you're doing, this isn't something most people should tear apart. So we'll put this off to the side, and we'll get into the drivetrain that's going on in here. We'll show you the cam ring that's actually doing the pumping on these, and we'll go into it from there. So we had a couple things we had to take out. It's kind of a pain to do, so we went ahead and did it off camera. We've got this bearing here that keeps the whole drivetrain of the pump lined up. We've got this little guy, some sort of valve that goes on the end of the timing piston. I think it controls return flow with position or something like that. Maybe it just helps keep it up against the end point. We got the cap for it that keeps it in there, and then we've got our little rollers here. So we'll go ahead and show you what's going on with the rollers. I've got to get this retainer plate out of the way first. I think it just keeps them sitting down there in the drive shaft. It might control end play or something like that too. But the important part, you can see there on the bottom, we've got the roller sitting right before that lobe. This is, I'd call bottom dead center of the pump. This is where the fuel starts, or rather the plunger starts, all the way out. And as this rotates, it rotates clockwise. You can see this roller climbs up this ramp, and that's what's pushing the plunger in, and that's what's actually delivering the fuel out the injector. So you've got the 3 slots there, the 3 rollers. They're all pushing in unison, and you can see the 6 lobes correspond with the 6 ports on the distributor head. And in this case, obviously it's a 6-cylinder engine. So for every rotation of the pump, which is half of the engine speed, this pump's got to go through 6 cycles. Each of these have to go up and down 6 times. So they're moving very fast. They're doing a lot of work. That's one of the limitations of this pump for the high performance. You can only move the fuel so fast, and as the RPMs increase, you're asking so much, because these pumps have to do really every cycle they have to pump 6 times. So one of the things that does change, and can change, is the cam ring. This one here is a standard output pump. There's the high output I mentioned earlier. They use the smaller pistons, what guys call a hot rod pump. They have a cam ring. I don't know if it has any more or less lift, but I know it has a steeper ramp rate, so it's forcing this roller up quicker, and that gives you higher injection pressure. If it is more of a ramp, then you're also getting more fuel quantity because you're moving that plunger further. So another thing we can look at while we're in here, we've got our timing piston here on the side. I'll show you. There's a little piston in there that moves back and forth, a little valve that controls it. So you can see if I push down on that valve, I'm able to grab the piston and pull it back and forth. So what this is doing, you can kind of see the plunger, the roller. We'll put it there at bottom dead center. As this rotates back and forth, it controls the position of that roller. So you're moving the cam ring, you're moving the lobes, and you're controlling where the injection start occurs. So by doing that, you're able to dynamically change, while injections are happening, really, where relative to the top dead center on the engine, the injection occurs. So that's how these engines manage the dynamic timing, or I guess these pumps. One of the problems with them, though, you're rotating these rollers around, and you're driving in those pistons at such high pressures, trying to compress that fuel. You're kind of fighting back. You're pushing up against this cam ring as you're rotating. So this thing, it doesn't maintain its position exactly. It probably moves a little bit. Even a small amount with every single combustion cycle. The piston's moving, and eventually these pistons start to gall up in the bore and they get stuck. Once that happens, the computer sees what's happening because it knows the position of the pump, it knows the position of the engine. So you see that the timing isn't where it's supposed to be. That's where you get your timing correlation errors. It sets a check engine light, and that's where not all of them, but a lot of the dead pedal problems come from. That's one way a lot of these pumps died. I've taken a handful apart, and everyone I've seen so far is all they've all had that problem. Whether or not they were dead pedaling at the time, that's up in the air. But you can see that the timing piston was on borrowed time, and that kind of comes back to just asking so much of this pump that was made for small engines. It's taxed pretty hard, and it does a decent job, but it obviously not forever, and that's one of the problems with these pumps. So the next thing we're going to do, we'll pull the cam ring out, pull the timing piston out, the drive shaft, and we'll show you a little bit more of that, and then eventually we'll get to the vane pump in the very front here. So we'll get this roller out of here. It may just be better to let it fall out. And then we've also got our drive plate here. This rides in the ridges on the drive shaft, and this is what drives those tangs. You can kind of show you here. It sits on there. This is what drives the distributor portion off the drive shaft of the pump. So we should have everything out of the way. We'll go ahead and yank this cam ring out. To do that, there's a couple little holes in here. I just like to pop some screwdrivers in it. And you gotta make sure the timing piston's in the middle, so that way it doesn't interfere. If you pinch them together and you work them back and forth, then you can get the ring right out of there. So you can see there's the interface on the bottom that sits in the timing piston. This little tab right here sits on a little tang on the drive shaft, and that's what rotates the sensor mount with it. So that's how the sensor always stays with the drive shaft, or rather with the cam ring. So it always knows bottom dead center on the cam ring. That way it's always starting the injection at the right time. So we'll go ahead and get this timing piston out of here too. Kind of got to push that valve down, pull it out. So this is the one that causes a lot of woes for the VP44 guys. This one's actually been, it's in pretty good shape. We had it coated and it hasn't really been ran in a pump yet. This is something kind of new I want to try to see if we can make a timing piston longer, but that's another story for another day. Really, this is how it sits in there, and it rotates back and forth as this piston moves, and that's what's controlling. I guess it's facing this way, but that's what's controlling your start of injection. Next thing, we'll pull the drive shaft out. It should come right out now. We got a spacer with it that may or may not. There we go. We got the spacer out, and here's the drive shaft. So you can see we got these three ridges. This is what the rollers are riding in. This is what's actually rotating them. We've got our taper up here. This is what's the gears bolted to. You've got your keyway and such. One interesting thing we found out the hard way: this tone wheel here is pressed on the shaft. So I think that has something to do with the fact that the VP44s have a specific keyway for the pump and other stamps somewhere on them. And I think that has to do with how this keyway is pressed on. The orientation of that is kind of to correct for them. You can get it close, but maybe not exact. So I think that's something they calibrate on the bench and they correct for with the keyways. And then I guess the last interesting thing here, we've got our sensor mount, and there's a little tab right there, and this tab lines up with this pin here on the cam ring. I'll try to put it together and show you a little bit. So as the cam ring rotates, we're rotating, we're moving that sensor mount. So like I said, the sensor is always lined up with, say, bottom dead center on the pump. It always knows the location, so it always knows when to fire that solenoid. And really the last thing to this is the vane pump. We'll go ahead and pull that out and show you guys what's going on in there. so we'll reach down in there and try to pull this cover off. You got 4 bolts holding it in. That's the cap for it. And you can kind of see down in there, if we zoom in a little bit, this has the splines on it, just like the drive shaft does. And actually, maybe we can pop it in there and rotate it around. I think it's going to block it, but basically this drive shaft rotates around, and it's just spinning these vanes, and they're pulling the fuel in. And that's what's, I guess, the high pressure stage of this pump, or I guess intermediate pressure stage. That's what's feeding the distributor. That's what's feeding the timing piston, and really a lot of that fuel is also returned too. So that's kind of doing some of the cooling of the pump. I'll go ahead and yank that out and kind of show you, kind of make a mess of it. But inside of there again, you can see we've got the actual pump housing. This thing comes out too. That's all separate, but that's steel machine for the vane pump, so it's not riding on aluminum. And you can kind of see the ports on the top, and again on the bottom where the fuel enters and exits at. So really that's the bulk of it. We've got pretty much a bare casing. Kind of explained all the ins and outs of it. So I think that's really all there is to these pumps.
All right, well, that was a great